This is a quick video to show how we can calculate some things with geometry and algebra to find a circumcircle. So what is a circumcircle? There's a lot of ways that you can think of it, but the simplest that makes sense to me is it's when you have a circle that goes through 3 points. Now, in Desmos Geometry, what I'm showing here right now is using the arc tool that allows you to just click on 3 points and create an arc. So I want a circle that's going to match this edge here. Now, if I were to try and guess where that circle would be, maybe the center is around like here somewhere. And then, oh, that's pretty close. If I were to try and match it to any one of these points, notice that I'm pretty close. And I could click on one of those and try to line it up just right. And it looks correct, but it's hard to be precise. Like I noticed the line gets a little bit thicker down here, meaning that it's spreading apart. So is there a way then that I can do that more precisely, and especially with using like a grid or some other kind of reference point? So I'm going to undo a couple of steps here. We'll take that circle off, take the arc off, and just start with our 3 points. First of all, I know where these 3 points are. They are precisely plotted in the plane with these x and y coordinates. I am going to make things a little bit easier to see though. I'm going to start by increasing like the boldness, the presentation of what's going on. I'm also going to add a grid along with minor grid lines and a pair of axes. So if I were to draw this on a graph, this is what it would look like. Now I see these 3 points. A lot of times we like to think of these 3 points as an actual shape, like a triangle. There we go. It's not required that you have the triangle there to do all the things we need to do, but it's helpful just to visualize kind of like where those 3 points are in space. What we really want to do is we want to add in perpendicular bisectors, and those are 2 words that add meaning to one thing. So perpendicular means it's going to create an intersection with 90-degree angles, and a bisector means that it's going to cut this space between the 2 points into 2 equal halves. So a bisector then is the same thing as like a midpoint, kind of. So if I wanted to find a midpoint between 2 points, I could click on the 2 points this way. I could also hover over the edge of a segment or the edge of a polygon, is what I meant to say there, and it will simply lock in on where the midpoint's going to be. And then I'll click. Same thing with this third edge here. Now I want to draw a line that is perpendicular to this point. Well, I could do that with like my line tool, and I notice that this slope is like a 1 or -2 over 1. So to be perpendicular would be a 1 over 2. So there's a perpendicular bisector right there. And like for this point here, perpendicular is a lot more simple because this line is horizontal, perfectly horizontal. So the perpendicular would be perfectly vertical. So now I've drawn those 2 lines in there, and they do in fact intersect at a specific point. Similarly, if I were to finish these perpendicular bisectors, I notice that this slope is -1 over 1, so my perpendicular slope would be like that. And again, we still have that same intersection, so all 3 of those lines converge at this one point. It's a very special point that's going to let us do some things. Now, that was just by drawing the lines manually. If I were to move this point around, notice that those lines kind of mix each other up and they don't converge anymore. So I want to construct a dynamic construction where each of these lines is going to adapt even if I change the triangle. So let's see how we can do that with the dynamic tools in this geometry tool. So let's undo these 3 lines. We're going to redo them with something that's more dynamic. Instead of manually creating lines with the line tool, we're going to create perpendicular lines. So when I use this perpendicular tool, it's going to ask me to click on a line and then line that up with where I want that line to be located. So it's always going to be perpendicular to that edge, but I can lock it in on the midpoint for its location. I'm going to do similar down here. And I'm only going to do 2 lines because we know the third line goes in there and it just starts to look a little crowded. So I don't need that third line necessarily. Now, watch what happens if I change the location of these points. They still converge no matter what. So even if I move this thing around, it's still going to converge somewhere. And those 2 points are going to cross. I could, you know what, just for completeness, I am going to do this third line, show that all 3 points converge no matter what. So all 3 of those lines are converging at the same place. So let's go back to our original start point here. All right, now let's talk about this center point. This point here is called the circumcenter because it's going to help us create that circle. It's the center of that circle that goes around this triangle, and in fact through those 3 points. So I can take the circle tool and now start at a center and drag to any one of these 3 points, and boom, now we have a circle that goes through those 3 points. Now let's kind of achieving our goal that we set out to do, I'm going to hide some of these things. I'm going to drag them down from the expression list just to see where they are. So I'm going to turn off, not the segments, but we do want these perpendicular lines, or the midpoints. We can leave the midpoints on. So I'm dragging a lot of this stuff down, and here's our perpendicular lines. So I'm going to hide those. So we're going to hide each of those perpendicular lines. And we'll even hide the triangle, because you don't have to have the triangle. And we'll hide the midpoints. And you can even hide these segments that were on the outside of the triangle. So now we have it. No matter where we move these points around, that circle is going to adapt and go through all 3 points. Even if I move them upside down here, we're still going to have that circle go through all 3 points, which is just kind of neat. And this construction with all these hidden pieces is what's creating it. But that's what we wanted to do, and we got it done. Almost forgot that we have one more thing. We have all this stuff going on, and we're going to hide a bunch of it just to kind of show something else as well. So we want to be able to, we'll drag a bunch of these back up here. Boom, 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 boom. We could just click the undo button and it would take each of these back up as well. But just to kind of clean up our space. So now we have our original 3 points, but we're going to hide the circle. And I'm going to hide these 3 lines just to clean up the canvas a little bit. And I'm really interested in this point there, but I don't need the midpoint. So I'm holding down Shift while I click multiple, and then I can hide all of them. So again, that point is like that center of a circle. And I know that the circle is going to cross through each of the, let's pull that circle down. It's going to go through all 3 of those points. So I'm going to turn that circle off now just for a moment. What I do know as well is that this center to any one of these 3 points is a radius, because it goes from the center of the circle out to the edge. And if you're not sure what I'm talking about, notice there, like it's a radius, it goes from the center of the circle out to the edge. I'm going to change the color of that. If I click on it and then I can click this 3-dot more menu, I'll change it to an orange color, make it stand out a little bit. So that orange line represents the radius. Now, an equation of a circle could be written as x minus, we'll say h, quantity squared, plus y minus k, quantity squared, equals r squared. And I'm going to add all of those there for a moment. Now, h and k represent the center of the circle. So that's this point right here. And if I were to drag that point down here, I could label it and it'll tell me what those coordinates are. But I could also read it from my graph where it's 1 in the x direction and then 3 in the y direction. So it lines up with 3 for y and 1 for x. What that means is that x, or h, the x value, is 1. You know, it's not, it should line up right below that center at x equals 1. But I need to raise this k value up to 3. Now I could have dragged it on the slider, but you can also just type it in here for more precision, I guess, if you didn't want to drag it by hand. And I noticed that the radius is not quite as big as it needs to be. So I'm going to drag this and say like, okay, it should be about a little bit 3.1, 3.2, somewhere in between there. But maybe there's a way I can find an exact value. Well, this orange line is like it's a diagonal distance on a grid, and we can use distance formula, or my interpretation is like Pythagorean theorem. What does that mean? It's like we have an a squared and a b squared equals a c squared. So let's color those two lines there. And those two lines will make green. So green, green, orange. A squared plus b squared equals c squared, or the leg squared plus the leg squared equals the hypotenuse squared. Well, the leg is 1, and the other leg is 3, and that's going to equal c squared. Or in this case, r squared, because it's the radius. Well, let's figure out what 1 plus 3 squared is. Well, that's 10. So we have 10 squared equals r squared. Well, that would mean that the square root of 10 is equal to r. So I have a couple of options here. And that's trying to graph it more as a polar type graph, and that's a little bit different. But anyway, so square root of 10 is equal to our radius. Now, if I have that, I could say that r equals square root of 10. And that's going to draw my graph there. And I could do it that way. I could also have just replaced here r squared equals 10 squared. So I can delete this r squared. Oh, not 10 squared. My goodness. That should have just been a 10. R squared is just 10. So now I can write this as an algebraic equation as well as the geometric construction. And that bell means that we are done. Remember, the link to this sample is going to be in the description to the video.